years experience, probably many of us on the call might have forgotten how it is to take a course. Okay, and if you have that issue, I completely understand. So in any class, you actually have a reference book that is important for you to read. But more importantly, from a lecturing perspective, these classes are intended to cover the most fundamental and most important ones. So you take the fundamental things, understanding from the course. I would actually share with you a couple of my screens and my RStudio in place, and we'll kickstart it that way. Okay, so the course is starts with giving an introduction to data science. Srini, just a quick question, Srini and Venkat. Have all the participants here participated in the webinar, or did someone did not participate in the webinar before?
I think majority of them had already attended, but I think we have a couple of folks who could not attend. Yeah.
Okay, sounds good. It's not important to have that, but kind of understanding. We start with introduction to data science, analytics as a formal definition, what it is, and what is big data, Hadoop ecosystem. So intention of this particular paragraph that I highlighted is for management folks to understand what is analytics, for everyone to kind of use high-level, big-picture view as to what is the field that you are actually playing in. So if you want to start a cricket game, you see usually Ravi Shastri going and looking at what is the pitch like and how's the environment and things like that. So that's what this is intended to do. We'll cover that today. The second one is the toolkits and utilities. We'll introduce RStudio. Little bit of the packages that we would do, some of my favorite packages that I have, the IDE and dev environment, what you have, a little bit of Git and Git repository that you could actually use and play around with, how to use source control, things of that nature. We will cover that today as well. Then comes the R programming. R programming, we'll talk about basics of R. So I approach R programming in two ways. Okay, so I start with giving scripts and doing a lot of high-level code that and advanced R code that you could copy and paste and execute it. Just to give you a highlight. So I would actually give you a clustering example. I'll give you an example for regression. I will give you a couple of examples for visualization, and I would start that way in R. So, and we would cover that today as well. Before going into fundamentals of R, which is like like in Java, right? Data types and vectors, notations, scoping, looping, vectorization of forms, all those things. Before jumping into that, it would be very dry, right? So instead, I would actually, in the first class, I will share with you all these things so that it's very interesting for you. You copy and paste it in the code in your environment. You would be in a position to do regression, do k-means clustering by yourself today itself, at the end of the class. Exciting, right? So, and even if you don't continue the course, as you can actually at least say, okay, I can do regression, I can do clustering, I can do visualization in R, and I know what I'm talking about, So, but that's not for you to discourage you to continue this course. That's for you to encourage yourself to come to the course for the next session. Okay. So tomorrow, what we'll do is we would cover the R programming fundamentals, like a little bit dry, but I will make it interesting with some of the quirks that R provides. I know, even in scoping, right? You can actually have out of scope errors in Java, a little bit of Java knowledge that I have. the indexes and all. So sometimes it's interesting when you get an error. So we will go through that, and I'll share with you a lot of scripts. So this way it's more interesting for you to run a script rather than attend a theory class. So I don't usually focus on theory part. It's just the first 1 hour of today. We will actually focus on the theory, some of the big picture stories and things like that. Okay, so that's how I take it, and feel free to interrupt.
Yeah. So my request would be, like, I wanted this, though it's an online class, I wanted this to be more interactive in nature. But when Arun is covering a very important concept, let him cover it till the end, and then you can raise your hand so that we can unmute yourself and you can ask the question. So I would request all the audience to be more interactive and ask any question. Don't hesitate, and the same question will be there. Maybe the rest of the folks are also facing the same question. It will be answered. So that would be, it would be great if you can ask more questions during the session. And the other one is, Arun, when you say R programming, so you are planning to give our students, like, how to set up the environment on their computers and all those instructions. Are you planning to give those?
Yes.
Okay, excellent. Thanks a lot.
Yes. Yeah, that's this one. Are you able to see my screen? Okay, that's the toolkits and the utilities and environments and R packages and RStudio and some of the popular utilities that I use.
Yeah. So Arun, can you please make it a single page, because I don't know, for me it is too small actually.
Oh, it's too small? Okay, I'm so sorry.
Not a problem.
Okay, these are important feedback that I need. If you're not able to see the screen, it's even more difficult, right? So
no. This is fine.
I appreciate that. Yeah.
Absolutely, this is fine. Good.
Okay, so we would cover the first section, and then we'll cover the second one today, and we will cover, as you said, as you know, I mentioned to you about R. I will give you a big picture view of R code. So I want the class students or people who attend, right, from day one. You might want to think yourself as a data analyst by day one, and data scientist itself, right from attending the first class, with the help of the code that I share. You should be able to do a regression. You should be able to do some clustering. You should be able to do some data visualization and some segmenting. And even if you want to play with or if you want to do some bragging rights, show your wife, show your kid, hey, see what daddy can do. If you're married. If you're not married, God bless you. So so just bragging rights with that. Okay, and then tomorrow we'll actually cover fundamentals of R. I'll try to go into a little bit, if we have time, to go about fundamentals of R today itself. Okay, so we'll try to do that. What's going to happen tomorrow is that we'll be deep diving into R a whole lot, because without fundamentals of R, and if you don't start the R programming language in the right way, I will share with you some complex script which will take only 2 lines for you to do. If you don't get what that 2 lines is doing, you probably miss a lot, because R is extremely powerful. It's scripted. For example, a very large clustering code that runs across several thousand data observations can be written in 2 lines in R. Okay, so R is very powerful, extremely powerful. The more that you use R, you will see that, oh my God, you could actually do such a big algorithm in just a couple of lines in your hands. So R is created in such a way that it's typewriter friendly. You know what typewriter friendly means? It means that you do less of typing. So it's designed that way. It's extremely powerful, and you could use it. So getting the introduction of R properly is very important. We'll do that. And we'll do looping, control structure, vectorized operations, which are very, very, very essential. And we'll cover those things deeply tomorrow. We'll also cover some of the markdown files. Tidy data is a very, very important topic. It would take about 15 minutes in itself to do it. How do you do sorting, summarization routines in R? How do you look at the data itself? How do you reshape it? Some of the popular packages, I use dplyr, data.table package a lot. We could do that, okay? And how do you read data sources, which is very, very important. Where do you start? I have an Excel sheet, I have a database table, I have Access DB. How do I connect? I have MySQL. How about HDFI data? How about even HTML data? And how can we actually get those and then do some text analysis? We would tell you how to read the data sources. So once you read it, you can do manipulation and do the regular expressions on top of it. Then comes the date issue, right? Date is a very big topic itself. It takes another 15-20 minutes to talk just about date packages itself. So that will be done hopefully tomorrow. I know it's a lot to cover. So those two is for this weekend. So what's going to happen the end of the weekend is probably I would send you via email. Probably Srini, if you're able to create a group for us in an email as a distribution list, we could actually do a reply all and share a few things. I'm going to ask you to do a few things, right? I'm going to ask you maybe to send a screenshot of your environment and create a Word document with 1, 2, 3 items. Maybe it's not a project, it's not an assignment, but take it in such a way that you will be given some things to complete. Okay. And I know that you're looking at my screen, but having my screen is easy for you to look at. When you do it by yourself, you might come across a lot of issues that only yourself can learn from. I would encourage you to do that. So we'll end up tomorrow with that kind of assignment, and I will send you what has to be done. And I'm expecting each and every one of us can actually respond back by next week. So when we start the course next weekend, so the initial first 15-20 minutes, we'll actually look at each other's points, and I'll actually highlight a few good things that I always learn from the people who come to the class. And believe me when I say this, you will be better than me when it comes to R, because it's pretty wide. Okay, so giving you a bigger picture, I don't want to bore you with this thing. What's going to happen next weekend? Next weekend is more exciting. This is my favorite, exploratory data analysis. We would go through the entire thing next weekend. So it will take 2 classes just for EDA. And we'll probably end up with giving you some summary notes on statistical analysis. So weekend after that, we'll look into some of the statistics. And many a time at that time, you would have actually attended 5 classes, and you would probably know a whole lot. But getting an understanding of statistics is more important for you to be talking in an interview, or probably in a different setting, asking whether it's validation. You might be in a position, looking at your experience, you might be in a position where you might be leading a team of data analysts. And how are you going to recruit them if you do not know a few fundamentals of ANOVA or chi-square? So we would cover that. Previous feedback, okay? Previous feedback I've received a lot. of feedback saying the statistics is where it tends to, I lose a lot of people in the statistics course. So I try to push it as farther down the line as possible so that I'll make it more interesting in the first initial 5 classes at least. And the 6th class, it might be difficult. So, but I'll try to cover a few things before itself based on feedback I've gotten before. So I talk about distributions. Those are a few important ones that you might need, and also I would only cover applied statistics, which is easy for you to digest it. Compared to if any of you, I don't see any of you are math major. I think one person is mechanical engineering. They would know more in that particular course. They would shine well. So that's a good one. The 6th or 7th class would be regression. So we would actually talk about logistic regression itself. That would take probably a single class, which is 4 hours. That itself. And then we'll cover machine learning, some of the plotting regression trees, classification trees. By then you should be able to document your code, publish your application. You should be able to give a data analysis report on any data that we give. And after each weekend, I would actually send you some of the homework kind of thing, assignment kind of thing, and you could actually combine with a group of 2 or group of 3. So I'll let you figure that out by yourself. If you need any help in organizing, we could actually help you to do that. So I would start grouping people right from exploratory data analysis, right from the next weekend. So you don't have to group this weekend, but from next weekend we'd actually group EDA. So by the end of maybe 8 or 9 classes, you should be able to do machine learning, deep learning, some of the neural network codes that's written. You can actually write your own handwriting and maybe do handwriting recognition, probably write some social media code to scrap Twitter data and do sentiment analysis by yourself, all by yourself, okay, without anybody's help. You should be able to do, and more importantly, understanding what you're doing is more important. So it's the understanding that will give you the confidence. It's not the code that will give you confidence. I'm going to repeat it like a mantra for a long time, so you'll be tired of it, because you will get code. You search something on the internet today, you will actually get code, and I get code like that too. Okay, Google is my good friend, and I'll actually cover that in today's lecture too. So you'll get a lot of code available in the marketplace, but most importantly, if you do not know the fundamentals of it, if you do not know what that thing is doing, some of the few tweaks, you might not appreciate each code. And last but not the least is, I would actually send you a capstone, which is probably the 9th or 10th class that we'll have, and we'll talk a little bit about capstone. And I think I'll not take more than 1 to maybe an hour and a half of going into capstone, and we'll close it very quick so that it's a lot of doing rather than explaining there. Okay. So any comments so far? Any questions?
Yeah, so in case if you have any doubts, I would actually request everyone to, if you have any doubt, raise your hand. I can unmute them. So I'll give a couple of minutes to raise their hands, and then I can unmute them. I don't see anyone raising hands. Okay.
So we'll start with okay.
Yeah, one request. I'm sorry to interrupt you, Arun. So overall, we have around 14 weekend days, including Saturday, Sunday, right? 7 weekends, 14 days, 14 sessions rather. So Arun, is there any way that we can map this entire syllabus or modules to session-wise for the so that
I just did that on the phone just now. I just told you that what are we doing it.
No, yeah, I know that, but yeah, in case if
it's
customer is looking,
right. I mean,
yeah.
I have two takes. You know, if you want to do it, we can do it. But you know, I would rather see in a point where I could actually cover as much as possible and as clearly as possible and as soon as possible. If you're able to do that, then we could actually, you know, cram it up so that we have more time to do our own codes and tests and do some projects. Okay, and in Capstone,
do it your way. Do it your way, Arun. I mean, basically, whatever is comfortable for you and audience. That is fine.
Yes. So you know, although we say it's going to take so much time, it is important. Also, okay, you brought me a good point. Thanks for bringing that up. See, the success in this is two-way street. Okay, success to be a data scientist or be a leader in the data science program is a two-way street. It would not be possible if you don't apply the same amount of time as much as you are attending the course. So the real reason why it's a weekend program is that, you know, on a weeknight, it's not for you to relax, but it's on the weeknight you read, you articulate. So don't worry about the news a little bit. Don't worry about other things. You know, just prioritize at least 1 hour a day to read by yourself. That's why I'm giving you the books that's needed. Maybe you can if you have a commute to work, take a printout and read it through. So it's very important for you to apply what you learn. Otherwise, it will go as a waste. You know. And data analytics, one thing I'll tell you is that if you don't use it, it will evaporate very quickly. So it's better for you to use it and then remember that, so that next time around, you know, you'd recognize what you have done. And it's important for you to go back to your own code rather than having somebody else's code. So this way you'll remember what you have. So please take notes and you know, also invest some time on a daily basis. You know, and if you all invest a lot of time, then we will actually finish the course quickly. If you do not invest time, then we'll have to go very slowly, and we'll take up the whole time, which many people may not prefer. So let's do it that way. And because I need time at the end for the capstone project, we would even do a couple of projects, and I keep getting a lot of project work, and you can even you know, do a couple of project works that I give you and have some multiple perspectives on it. So the more the number of projects we do at the end, the better it would be. So we need time towards the end. So yeah, you know, let's do that way. Okay.
Yeah, Arun, I think Ranjit, he has a question that how much do you cover on Hadoop, and do you cover the Hadoop file system? So that was his question actually.
Okay, Hadoop. I don't have an installation of Hadoop in my laptop here, where I'm actually training. You know, I do at a workplace, and I used to be a Hadoop architect, where I did that in my past life. About 3-4 years I did Hadoop ecosystem. I'm not intending to cover that a whole lot here. The real purpose is splitting data science versus Hadoop. Okay, that brings up another point that I want to mention here. Fundamentally, there's a lot of confusion in the marketplace when you say data analytics versus data science versus a big data programmer versus Hadoop ecosystem. Many people who are very new to data science, they think knowing Hadoop ecosystem is being a data scientist, or in many sense, being a data scientist means you know how to run programs in parallel. That's not true. Hadoop ecosystem is and a Hadoop environment is a bunch of tools. It's a you have Hive, you have data structure, databases, all those things. It's for you to enable parallel programming, parallel processing, so on and so forth. So you could actually run all the things that you want to run in a Hadoop ecosystem in an environment in your own laptop in RStudio and write your own R code. So that when you have an Hadoop environment, you can parallelize what you have written. So I would actually cover that in the end. Towards the end, we'll talk about R Hadoop and how to parallelize and things like that. So one of the capstone project that we'll deal with, we'll have a bunch of observation, maybe a million observation in time series modeling, things of that nature. It would take you about 10 minutes to run a piece of code. So when you're dealing with large data sets, and if you're running a clustering algorithm that takes 10 minutes for you to execute it in your laptop, that's when you will appreciate Hadoop ecosystem. So my short answer is, data scientists use Hadoop as a tool to make it easier, make it quicker to process multiple data sets. But where is the question of reducing the time if we do not even know why you will use the engine, right? So Hadoop is a parallelized engine, very large engine that could take your program and then parallelize it very quickly, generate the results. So we would cover the fundamentals in the first class. After that, we'll forget about Hadoop very quickly. That's my answer to it. But if you want to take a deeper look at Hadoop, maybe you could actually do a AWS cluster. I can help you out with it, a few things, and then deploy your R program that you're writing in our Hadoop environment and put it using our Hadoop in the Hadoop ecosystem, ingest multiple data sources in Hadoop ecosystem and run your program in our Hadoop for your capstone. And that would be a really good exercise to do towards the end if you want. But we'll not cover in depth of Hive, in depth of big queries or Hive queries, or even Zookeeper, how to visualize data that has been ingested in Hadoop. All those things we'll not cover in this particular session. It's purely a data science course to call yourself a data scientist, a data analyst, and for you to look at data in a different way.
Yeah, sure.
Okay.
Yeah.
All right. So let's go.
Yeah, I think someone else is asking, Chinmay, I think he's asking, can we get a chance to execute projects even after completion of the course in case time is less to cover less projects? Yes.
That's a good question. So Chinmay, yes, we would definitely take some time to execute the project. So that's why it's important for me to not to rush through a lot of things to begin with, especially the theory part. Very quickly, we'll actually cover that, so that towards the end of the course, you will have time to execute the project. And then in the capstone, in my experience, we would have a 1-hour class to explain the capstone a little bit, give you kind of hope, and then ask you to execute it. So at that time, we'll actually finish the class in 1 hour, and then it will be a lot of going back and forth at that time. You'll write a piece of code, and I hope that fundamental questions will not come there. You would actually go to Stack Overflow or Google for fundamental questions, like why is that I'm not able to scope this particular operator in this particular looping function that I wrote. Those are fundamental questions. You can actually take a look at Stack Overflow and other things that I suggest you to do. But we would actually talk about how to approach whether you'll do SVD decomposition or regression trees, or would you Would you look at the problem like a clustering problem or segmentation problem first? How do you segment the data? Those type of things we'd be discussing that a whole lot during the time that's available. Okay, and that would be going back and forth, and all the questions that is being asked will be answered in public, unless it's a personal question. So all the questions will be answered. So more questions that comes around, everyone will be benefited through the entire class. Okay, so that's my take on it.
Thanks, Arvind.
Okay, great. So let's get started. I'm glad we'll probably give a break. But if someone wants to have a biological break, let me know. We can actually do that. Okay. So this is what I had. I wanted to talk about levels also. The last but not the least comment on the course and everything is the levels that we have. So application of analytics all are at intro level. R programming is also at intro level. The moment that you get into data exploration, data manipulation, you are considered a medium performer. Statistical analysis is a little bit of advanced, medium to advanced. We will cover that at a medium level syllabi. Once you hit regression analysis, machine learning, those are very advanced level courses. So you should be in a position where you could actually take interview calls, ask questions. You could lead a team if you're having more than 10+ years experience on an average. It looks like you could actually take up a leadership role and lead a team to and execute it to success. So those are some of the things that you could do, at that level. Okay. So let me close that. Okay, what is analytics? Let me open it up. I hope you're able to screen. And let me use this pen, the highlighter pen. Okay, so analytics refers to use of statistical and mathematical techniques. So we'll be focusing on algorithms and statistical and mathematical techniques in order to view data in a different way. So think about you think looking at news a little bit. Look at the trends. Look at what's happening in right now. One of the project that the PIT project, myself and my colleague are working on is to create trend analysis on the poll. I know a lot of pollsters do that, but from a data analyst perspective, how we see Twitter's impact of Trump versus Clinton. What is the social media looking at? Which has more impact? What is the strategy that people follow? So the data will actually tell you that. So we could actually look at trends and opportunities. And those trends will tell you whether you need to invest in inventory, invest in optimization routines, or invest in growth. Okay, so answers will be provided. Decision making can be done for executives through data analytics. You may be able to do faster and better decisions, and based on data that is being available to you. So you can actually look at anything with the data. For example, you can actually take a daily usage of your credit card. Go back to your credit card and see how do you classify things. And if you classify, then can you actually predict next month how much in each classification, right from groceries, okay, provisions and those things. So we'll actually do a small project on exploratory data analysis in the next class that we'll do. I'm going to give you an assignment to take up your credit card bills and kind of do classification problem from that. Okay, so those are the things that you can actually do analytics on. So that's what will give you. It would eventually give you a competitive edge. It will tell you what you have not seen so far, it'll give you a better perspective. So that is analytics. Okay, or in other words, it is used to identify and observe trends, behaviors, and opportunities or risks that are not otherwise obvious. Okay. This is a slide that we have already seen. Where does advanced analytics or data science sits in? Okay, when I say advanced analytics and data science, both mean the same. So data science and data analytics are the same. You know, it covers right from visualization, descriptive analysis, and predictive analytics. So these are the three things that we'll be covering. We'll not cover a bunch of database concepts or data warehousing concepts. You know, we will not be focused on reporting also. So those are some of the tactical ones. We'll be going into much of the strategic space. So if you want more leadership, more visibility in your organization, I would suggest you to go from take a strategic route. The person, I got a quote recently. One of the quotes says, if you have data, let's see what data says. If you do not have data, and if we all have opinions, let's go with my opinion first. So that's the quote, a very famous quote. So opinions, you know, everyone has an opinion, and sometimes it's like armpits. So, you know, let's look at data itself. Okay, so it needs a lot of subject area. We'll actually drill into a little bit of subject areas. We'll give some examples on pollution, air pollution. Some of them on healthcare. We have healthcare data that's available. We have claims data. We have more than 2 billion observations that's there on the property and casualty claims information. We could actually do a project on Capstone on that. Okay, so when you talk about when you talk about data analysis or visualization, what does it contain? It contains graphs. Okay, creating graphs, charts, formatting, statistical visualization. With how much confidence can we say a few things? Those kind of things. When it comes to prediction, we'll actually say anomaly detection, classification, estimation, forecasting, and optimization. So those are some of the things that we'll be covering. Descriptive is more of segmentation and scoring. You know, can you actually score a few areas and segment few areas and then treat that into a target market? So we'd actually do that. So these are some of the fundamentals of BI analytics. There are multiple social media startups. We would actually take a couple of data from iCentinium. I will actually send you an email with the data link that's being made available from the social media startup companies. We'll take up their cleaned data from there, and then we'd actually look at markets from there. Okay, but before that, I want you to have a very good understanding of where analytics stands. This is extremely important for you to understand the problem. So if a data analyst does not understand the problem, we would probably not we'd be doing something in the data space. Okay, so when I recruit people, I see that a lot of people who have just finished masters in data analytics course, they know what are all regression and all these algorithms and all, they know very well. They know what is chi-square testing, t-testing, and everything. But where they do not know is what is the applicability of it. They do not know how to apply, where to apply, things of that nature. So it's extremely vital for you to. I will take a note so that I will send you the McKinsey report. McKinsey report, I will send it to you so that you can actually read it. I think it's a 8 to 10 page document. So it's important for you to look at value creation. Okay, so there could be a lot of value creation, right? You can actually say, oh, I'll do trend analysis to do segmentation, but your question should be, why do that? Okay, so let's not go into a lot of science on dealing with that kind of a problem. McKinsey did it for us. So whatever you're going to do, entire thing should be will be part of these 5 different value creation with any data project. Okay, 5 different viewpoints. Okay, number 1 is increased transparency. You can reduce time to market. You will know what is going on, and that would lead that increased transparency value creation will lead you to look at segmentation, look at target market analysis, look at the social scoring, look at your existing portfolio detection, book of business analysis. All those things will be forming from that increased transparency value creation. The second one is improved performance and real-time analysis. Okay, improved performance. So take for example, I have been in a position where, and Venkat Vadadi knows this also. We worked in an insurance company, and that insurance company, the nightly batch cycle takes more than 8 hours. So the nightly batch starts at 10:30 in the night, and it ends up maybe by 6 or 6:30. That's when it finishes. What does it do in the batch cycle? It will reconcile all the operations that happens in the insurance company itself from a company-wide. So consider an insurance company like Geico. Thousands of transactions happens. I ruined my car, or there is a claim, there was a payment, there was a missed payment, there was cancellation, there was someone wanted to get a quote. All these things have been done in a single day, right? So in the night, what happens in the nightly batch process? The entire data gets accumulated. All the transactions in effect at 12:01 a.m. And how can you actually systemize it? So all these data warehousing jobs that keep running, it runs overnight, and it reconciles and goes to the right billing system, and then invoice gets generated based on the nightly batch process. Cancellation happens. A cancellation notice gets printed the next day based on the nightly job process. One person is denied a coverage because the nightly batch process said the policy already got expired. Okay, so that happens all the time. And we worked with the project 2 years ago with a company called Swiss Re. It's a reinsurance company. It's called Swiss Re, and the reinsurance company had done a data warehousing project, something very close to the previous experience that Venkat Vadadi also knows. Something similar to that. It took about 19 hours. They used to do some project with 19 hours. So we took up that job, and we said, okay, there can be 2 approaches. It's not a data science project. It's a data project. So number 1, we looked for efficiencies in the job itself, how the job could be handled very well. Number 2, we were looking for tools that could better from an operation point of view. So that led into talking about big data. So we actually put that entire process in a big data ecosystem. It's called harnessing. So harness big data. And so we used the harnessing aspect of it, put the entire data into a Hadoop ecosystem. Actually, nothing but parallelized it. So when you do parallelize the job, it runs so much faster. So if you have maybe 20 nodes, it would probably reduce the job by 10 times. Okay, 10 times. So the one that was running for 19 hours, it actually ended up running in less than 20 minutes. So that's something that's the improvement of performance. Okay, data science example. You can actually do a root cause analysis. Why such behavior happened? Okay, I'll highlight another example. Again, an insurance company, one of the large life insurance company. Their CEO came to us and said that did not come to us. Their CEO went to public and said that they had experienced adverse selection in the marketplace, and because of that they did not predict. They wrote business 20 years ago, and after 20 years today they are facing a lot of claims for some reason. So what happened? What happened with that insurance company? They're losing a lot of millions and millions of dollars. They're losing all of a sudden. Why did that happen? So root cause analysis is a very good data science in itself. Everyone wants to do root cause analysis. Why did they grow? Why did something happen? Why did they have so much claims? Why did in a manufacturing example, why are there so many defects that's happening? Your data will tell you. If it is a defect with the with the product, defect with an operation, defect with a single company, defect with an employee, or whether it is a defect with the raw material. Your data will actually tell you how to deal with it. So for this particular example, going a little bit more details, we took data called FARS data. I will actually share with you the FARS information also. We will use that data for us to do some projects for exploratory data analysis as well. Okay, I will send you that link for FARS data. So what FARS data tells you is all the accidents that has happened and what is the outcome. Okay, so in the US, all the auto related major accidents that has happened, and whether it was a fatal accident or not. Fatal accident means whether someone died in that accident or not. So we took that data and we merged with another data source called DMV data source. Again, this is all publicly available, and the AXA, which is that company's CEO, did not. Before even we went and pitched to that company, we had to do these public data sources and doing some validation. So we took and we did some really funny, curious way of looking at it. So we said, okay, let's look at the data itself and see which are the top states that have issues. When we looked at the top states, I think Rhode Island and Massachusetts came in the top 10. One of these two are some small states. Okay, Rhode Island is a very, very tiny state. You cross Rhode Island within 1 hour from one point to another point. Okay, so that came in the top. I'm like, okay, something wrong with the data itself. Okay, because there are not many roads in there and not many drivers in there. So then we figured out that we had to normalize the data. So we'll cover the topic called normalization. You will hear me a lot to normalize the data in the projects that we'll be dealing with. So what is normalization is to make it equal, make two sets of data equal. So if one set of data is all in hundreds or thousands, the other set of data is all in ones and twos, you cannot actually compare these two. So in order to compare these two, you actually do something called as a z-score. We'll talk about z-score in data analysis very, very soon in the next class. So we'll do a z-score. When we did a z-score on it, which is basically removing the mean and dividing it by the variance of it. Okay, so when we did that, we actually normalized it, and we found that the top 7 states are being exposed there. Then we went to present it to the company. The company said those top 7 states are the top 7 states that they write business in. Okay, so one of the reasons what the data showed, I said one of the reasons is that there are a lot of traffic fatalities or incidents in the states that they write the business in. So one of the outcomes is to move out of the states and focus on other states where they could actually have some safe writing. So those kind of decisions could be taken up. Okay. Third point, improve customer segmentation. We spoke about that. How do I actually do target market? How is my target space looking like? Again, example in manufacturing and retail industry, who can I actually target? Who are the target audience? Let's say even a pizza shop or any of the retail outlets, they want to see who is their target market. Okay, and even in corporations, we'll have to see who are the supply chain, who's producing more, who's delivering more, and which segment goes there. Based on that, we'll have to look at the pricing, we'll have to adjust the product, we'll have to adjust availability of it. A lot of logistics goes in there. So again, data will actually tell you that, and it's very, 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 very simple to do those things. The fourth one is provide actionable insights, which would be reducing the exposure of in your data set itself. So what if you are not looking at the data, like what AXA did? AXA did not look at the traffic incidents, and they kept on writing business in states where there are a lot of traffic fatalities. They did not even look at it, because life insurance has nothing to do with traffic, but it proved wrong. Life insurance has to do everything with traffic violation. So you'll be surprised that the industry do not look at it at all. Okay. And then another one is how to sample data itself. We will cover that in the next class, how to sample data. Let's say you actually have observations, maybe a million observations. When I say observation, it's the word that we use in data science for a row. Okay, so think about it like a table. In a table, you have multiple columns. The columns, the name that we used for columns is called variables. Okay, we'll talk about what type of variables and all fundamentally maybe tomorrow, but we'll call those columns as variables, and then we'll call the rows as observations. So the rule to tidy data is that you'll have all columns, all variables represented in an observation. And not a single observation should have a variable. So we'll talk about that a lot. So how do you sample from that 1 million observation, and you want to sample 10 or maybe 10,000 or maybe 100,000 observations, a sample, so that you can actually look at it. Even in surveys, right? If you want to do a poll survey, or if you want to do voting, you cannot actually vote or survey everyone. How do you sample? And that sample should be the representation, the accurate representation of the entire population. So there's a lot of science behind it. We'll do that. The fifth one is to create new business models. So basically, some of them are GIS based information. GIS based means geographical information, so spatial analysis, Google Maps, those kind of things, and unstructured analysis. We'll do a project on unstructured analysis. That's my favorite as well. Okay, so this is something very, very important for you to do. Any use case that I create, I have these this chart that I prepare. This is personal to me. I've not seen many data analysts do this, but it's very, very essential for you to ask the right questions. A data scientist, as a data science, you need to ask questions, proper questions, okay, business questions. Before going to the data area or data subject area, do not jump into the data. Jump into the business area and business objective and outcome. So once you know the objective and the outcome, you will have to run something called as hypothesis. So eventually, so that you can do a hypothesis test. With what confidence that you can actually say that your hypothesis or null hypothesis is, with what confidence interval can you actually say your hypothesis has been accepted or rejected? Okay, so you fail to reject a null hypothesis. Those are all some statistical inference jargon. I will actually explain to you. It takes a while to kind of understand that, but we'll get into it eventually. For example, I'm not going to focus on everything. I'm just going to focus on the easiest one. Let's look at sales and marketing, right? So sales and marketing is like predict which policies will be renewed, predict which one can be, have been lucrative policies. That's the business outcome. So we want to predict which policies are. Another example is I want to cross-sell with my existing customers. I want to cross-sell with a new product. Cross-sell is very important. And how can I actually share a peer group with a current customer? How do I group the customers? Okay. So what is the outcome of it? The outcome is I can actually incentivize better customers. You always want to get recognition to the right people. And you could actually have persistence and maximize profitability. You could do widening market share. Okay, sales cost can be reduced. Identify new markets with very optimal risk exposure, and improve profitable exposures. So these are some of the outcomes that you are looking forward to. Then finally, those outcomes. So it goes like this. You have a business objective, then you get a business outcome. From the business outcome, you actually do something called hypothesis. The hypothesis is what factors will influence. So think about it. What factors will influence a renewal? Okay, what is the likelihood that a renewal can be predicted? Can customers and peer groups have some similar attributes? Maybe age. Maybe you're all from a similar language. We all speak South Indian languages. Maybe we are distributed far away, but we still have the same lineage. Maybe it's geographical ties. Maybe it's similar interest groups like data analysis groups, so on and so forth. Okay. Does the entire peer group have risk or churn profiles? Can we actually predict through that? So these hypotheses will lead eventually to the analytic techniques. So please pay close attention to this, because I'm going to ask you if at the capstone project or towards the end of the project, or if you're looking at data and you say, okay, I'm going to segment it through this, the question would be like, why you do that? Okay, what is your objective that you want to do it? And what are you trying to create a story with, right? So this is very, very important eventually during your presentations and answering it. Okay, so then finally you do logistic regression, OLS, and decision trees in order for you to bring up this question. Then you actually do clustering. Then, because you want to do peer grouping, I want to do cluster analysis. I want to do similar projects. So let me do decision trees. Okay, I want to actually do risk or churn profiles. Let me do logistic regression. Even machine learning, like neural networks, I could actually apply for this particular problem. Okay, so on and so forth. So the analytic technique is when people will jump into it. Popular behavior is that people actually jump into this section right away. This is where people jump into as a data sciences, but they ignore the previous three. So that's very, very important for you to do. So once you actually develop that mindset, then you look into how do you do this data subject areas, which is the subject areas. I don't want to talk about KPIs because it's a BI topic. This is BI, okay, and this one is analytics. So let's talk analytics here, because this is the class for analytics. in the subject area, then you'll say that, okay, I need data. This is the data that I will need for this particular analysis. Okay. So if there's any questions, let me know. But I'll go right quick into analytics in several stages. So analytics can be actually classified into 4 stages. Okay, descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. We will cover that in greater detail. But this is another extremely important topic, a fundamental topic. It's called MDLC. Okay, like SDLC. If you go into a software programming course, they all start with SDLC. SDLC stands for Software Development Lifecycle. Like that, can anyone tell what is MDLC? Oh, I know that you're all mute, so okay, I cannot ask that question here. MDLC stands for Model Lifecycle Development. Okay, so anything in analytics is all about creating a model. Okay, so I don't know where my cursor is. Sorry. Okay, MDLC. So MDLC stands for Model Lifecycle Development. But very few people understand that modeling is the third or the fourth operation. It's only 20% of data. 20% of data analysis is model lifecycle development. But model lifecycle development goes with these operations. First of all is the business understanding. I think we covered it all. I think we covered that with McKinsey's study and some of the examples that I gave you, some of the project examples that I gave you. I think and the webinar that you attended covered business understanding of it, which is the objective, the situation, what are the goals, what are the use cases that you're dealing with, what is the architecture, what is the plan eventually, right? So that's the business understanding. Once you have the business understanding, then you go into the data realm, which remember I told you in the previous slide. Here is the data subject areas. So the what are the data subject areas is what we'll actually cover that, right? So then you get into data understanding, which is collect the data and sample that data, describe it, then you do exploration. So exploratory data analysis is something that we would be covering that. And then verify the data quality. So these are some of the things that you need to do with data understanding. So after that is the third part, which is called the data prep. We spend almost 60% of the time in prepping the data. I would say data prep and data understanding is about 60% of the time we'd be spending that. So it's very important. So we would be covering a lot of R code for doing that piece of work for you to get accustomed to R, how we would do data prepping validation in R itself. But the foundation is this: you select the data, cleanse it, select it, construct the data source, integrate it, and format it in a right way. Okay. So that's the data prep that we do. Then comes the modeling phase. So modeling phase is all about using the right models. Remember, I told you about the analytic techniques. That's when the model comes in. So this is where the model comes in. You do linear regression, you do neural networks, you'll have to do cluster analysis, maybe k-means clustering or hierarchical clustering, ARIMA models, time series models, so on and so forth. Okay, so that's the model. First, you will have to select the model, which model you want to select. Okay, then you will have to design the test correctly. Then, because without performance testing, you don't know whether the model performs very well or not. How do you split the data into test set and training set? Okay, so test and train set and validation set. There are three. So once someone gives you data, you will be first splitting the data into testing set, training set, and validation test sets. Then you build the model, and then you do the assessment of the model. Eventually, you'll do the evaluation of the results. Then you will have to do confidence, how much of the confidence. Then eventually you'll go into model development of one more model. Probably you'll do a couple of models and see which one performs very well. Finally, if there is an ensemble modeling, which is a combination of multiple models, in order for you to give a lift for prediction, you could actually do a combination of that during the evaluation phase. Finally comes the deployment phase, where you will actually do indoctrinate that model into a production life cycle. Okay, so you plan a deployment, you'll do monitoring and maintenance of that particular model, how it is performing. Let me give an example. It's kind of dry. If, let's say, I say that for target space, which is somewhat age discriminated, right? So if I segment the market into Gen Y, Gen X, and Gen Z, okay, then for Gen X, Gen Y, and Gen Z, what products and what is the time frame that's available, it can be actually said. So let's take an example. Everyone have shopped in Amazon.com. Amazon knows whether you're a Gen Y or a Gen X or a Gen Z. Based on that, what type of products that it can actually do affiliation with. Okay, so that's an example that we can actually talk about. Okay, I'm just looking at the text message. Only now I said, can you make it single page? Okay, only now I read it. I'm sorry. Okay, good. So you plan the deployment. So that's when, once you deploy it in the production, you will see in the screen that certain products will be available. Hey, do you like speakers? I'm considered a Gen Y in the borderline. Okay, thankfully. So it says, do you like the Bluetooth device? Do you like the speaker device? That's what Amazon tells me. But if my father or if my mom logs into Amazon, they actually see cassettes, videotapes, and some movies. That's what it says. Do you like to buy a movie from here, or buy the CD from here? Because they know that they're retired people. So Amazon does a lot of classification. So once you deploy the model automatically classifies it. Automatically the data gets classified, and it automatically brings the right data in front of you. So that's what it calls, when I say deployment, that's what it means. It means that you have put that in place in order to do the prediction in the right way. So similar to weather prediction too. So once you create the model and you deploy the model, that model will tell you that whether the hurricane is going to hit in this particular time frame, or whether the rain will be coming in what confidence. 80% chance of rain, 20% chance of windstorm, things like that can be deployed. So that's the deployment example. So knowing MDLC is extremely important, the baseline of it. So if I have to highlight what is the highlight of this particular course, today's class, is 2 slides. Number 1 is this: how do you approach a problem, and for what, value creation, and then what is MDLC. Okay, let's talk about a few more. Let's go deeper into what we just talked about, MDLC part of it. Okay, trends in analytics. Okay, you want to differentiate customer experience, gain market share, or drive corporate culture. Okay, which is benchmarking. So if you want to benchmark yourself and your competition, so let's say someone said that you're working for Citigroup. How is Citigroup performing in that particular portfolio compared to your closest competitor? Okay, it might be Malik's company, JPMC. So how is JPMC compared to Citigroup? Okay, you can actually see from a customer experience point of view. You could actually go to data sources and then get that. You could actually look at the stock and then see how the two stocks perform very well. Even if you want to look at your own analytics, where which of the stocks have performed in your portfolio that you have invested in, you can actually look at that as well. Okay, any process change, operational excellence, cost saving is a very, very high performance. That's why people engage analytics. So people engage analytics mainly for cost savings or increasing their performance. Okay. Okay, trend analysis a little bit more. Okay, there are a lot of real-time analytics and BI. So ClickView and Spotfire and Tableau. So these three are pretty much leading the BI space for real-time analytics. ClickView and Spotfire and Tableau, they all have dashboards that are pretty quick to be applied. They take crystal reports and make it more customer friendly and more real-time basis. So you use tools like SPSS and Cognos and so on and so forth for BI platform. So once you have BI platform, you can actually take ClickView or Spotfire to integrate multiple reports and put it in a single dashboard that could be visualized very quickly. Okay, so that's a kind of a descriptive reporting in itself. Okay, then rules engine. Rules engine is a pretty big thing. BREs is really important in classification. So when we talk about decision-based rules, we'll actually talk about it. So far, I know as Java programmers, you all have done deterministic rules, which means that if this data comes in, if this is the state, this is the profile, this is the age, this is the marital status, you perform this. Okay, for decision making. Just think about if it is an analytics rules engine, meaning if 20% of the data comes in from here, then you apply a few routines. So you can actually make a decision-based rules like that. And what tool you'll use? You'll probably use decision trees, like the name goes. You know, you actually make a tree, and 20% of the people in this particular segment have so much preference. 30% of the people in this particular segment have these preference. So it goes into decisions. So it helps you in generating your rules for any type of arbitration or even selection. Okay, so how do you classify analytics? So broadly, analytics are classified into two spaces. Number one is supervised. The other segment is unsupervised. Okay, simple classification. So analytics is classified. Analytic techniques are classified as supervised analytic techniques and unsupervised analytic techniques. Where will you apply supervised techniques and unsupervised techniques in which scenario, right? Unsupervised is used to detect new patterns. The keyword is new. The patterns that I do not know that will exist in the future. In order to detect those new patterns, unsupervised analysis will be used. Iterative approach also will be used for unsupervised ones. We can actually talk about link analysis and cluster analysis later, right? Those are the techniques that you use. Supervised analysis is you assign risk scores, some of the things that we already know that, okay, this is the segment, this is the somewhat deterministic, then you can actually assign those scores for those things. So which means that supervised, in other words, means you know the outcome of that event. So results of unsupervised. So you actually do a cluster model from here, and once you do a clustering, you use that as an input to the supervised learning. For example, you take a bunch of data sets. Okay, you have data sets here, here, here. Okay, this is could be the time. Okay, and this could be maybe efficiency. Efficiency is the eta. Eta is the efficiency, or this could be something else. Okay, now with related to time, you actually have these observations. Okay, these are the data points. Now I use unsupervised learning to cluster it. Maybe I'll cluster the top elite ones like this, and which is based on the time lag, and this one will be called an outlier. Okay, so this is the outlier. We do not know how to what to do with this particular point. Okay, so this is one way of looking at it. The other way of looking at it is looking at it in batches. You take a window, and then you slice it from an efficiency point of view. Then you take another window, and then you slice it again with related to efficiency. So based on that, based on the techniques like clustering, today I'll show you a clustering analysis before we end the session today. So this cluster analysis will do these kind of clustering together, and see which one is an outlier or abnormal case, and take it from there. Okay, so the popular techniques used for unsupervised learning is link analysis, direct links between entities for circular trading, and so on and so forth. Clustering example, where you can actually have abnormal group, like this is the identified, this is the abnormal one, or rules generation, classification, those kind of things, or text analysis, unstructured learning, natural language processing. My focus area is on natural language processing right now, so we can actually do unsupervised learning that way. Supervised learning is all our neural networks. I actually train it. For example, your cell phone, right? Your cell phone has a model in the chip that is being deployed. It remembers how you say a single word with my accent. So I can actually call chair, or chair. Okay, so all are different pronunciation of the word chair, and the cell phone detects how the person pronounces the chair, and it's the basics of neural networks. You start writing A, and you all say this one, and you train this one as the training set. Okay, and give it to neural networks and say that, okay, identify all these things as a word A. Okay, so this is the training set. Now in the testing set, you give this one, and then ask it to test it whether it is detecting as A. So here, obviously, the training set, you do not include any of the small letters, so you'll not get the outcome in the testing phase. Okay, so this is character recognition. Okay, recognizing a character or anything of that matter. So the outcome is already pre-known, and you're using the past outcomes to train the model in order to test the future outcomes. That's the example of neural network. That's the example of supervised analysis. Decision tree is also the same way. You know the classification before. Now you apply analytics, and you tell that, okay, this is how it is done. Okay, logistic regression is another example. Let me draw a graph here. Okay, I would actually okay, now this is the example. If I ask you a question, join these dots, what is the first thing that can come to your mind? The first thing that will come to you is do a line like this. Okay, but as a logistic regression person, I would actually draw a line like this. This is how I'll join, so that I can actually predict what's going to happen in the future. So the futuristic point might be here, might be here, might be here, but on average, this is the trend that the future will look like. Okay, so that's what logistic regression is all about: seeing the data and then drawing the lines. So I hope I answered the question. So if someone asks, you can ask someone. If someone says that, okay, is it unsupervised analysis or supervised analysis? Okay, and we'll use a little bit of unsupervised and supervised analysis in our examples. Okay, the next few slides that I'm going to show you are all about a few analytics processes and its description. We will get to it, but why don't we have a break? Maybe I'm feeling thirsty a little bit, so I'll take it. It's 9:45. How about taking 10 minutes break, and then we'll reconvene, and if everyone are okay.
Yeah, sure. Thanks, Arun.
Okay. All right. So any feedback by then, it'll be appreciable. Okay. So
yeah. Meanwhile, if you have any questions, feel free to ask your questions in the question section, and if you really want to speak up and ask questions, then probably you can raise the hand. I can unmute you. Okay. Thanks.
So everyone are back. It's
I guess so. Yeah.
So everyone are there on the phone. Can we start?
Yes, we can start. Actually, yeah.
Okay. So it's 10 o'clock. We gave a break until 10. Okay. Hopefully all are here. I'm actually I took a quick break for hydration, so that's good. Okay, so looks like there was a question on NLP and NLG, right?
That's right.
Is that the question? Okay, so NLP is natural language processing. Natural language processing consists of wider range of processes that you will actually do in order to take up a representation of canonical forms of language, dependent clauses, detecting sarcasm, seeing how the machine could be reading words in a or group of words in a different way. And what do people mean by what they say? Things of that nature. NLG is the machine representation or logical form of what the NLP has to perform, right? So in order for NLP to work, these days they actually have something called as a dictionary, which could be manually created or it could be machine created. When machine creates it, it's called a natural language generation. The machine detects few ways of writing, and it would classify those into a separate form. So you can actually say the same verbiage and mean the same by telling it in a different way. Okay, so how do you aggregate all those sentences into one form? And so the machine generates a separate form which will be used. So that's what is called natural language generation. So in my own words, in a simple words, if you extract the logical definitions and form a lookup table, or even we call it a centroid of the cluster. So you have all the clusters and you have a centroid of the cluster from a textual perspective. Those centroids are the NLG in one sense. So machine represents the sentence or a bunch of words in a specific format, and that format is called NLG. NLG is, in other words, is a data dictionary that is centroids of all the similar clusters that mean the same way. So this is used for you to have efficient detection and efficient analysis of it. I see some UCAM. Okay, good. So let's proceed where we left off. Okay, now I'm actually going to take the next 15 minutes to tell you all the analytic processes and algorithms. We'll take up all those things and then we'll describe it. Okay, in as simple as possible. And I will share with you these descriptions also, so that you don't have to copy when I'm actually speaking. And I just want to tell you that, don't dive deep today. It's just for you to understand it. Understand the first class is for you to know a lot about how do you approach, what is the big picture, a little bit of theory, and what are all the techniques that you will be using. Okay, so these are some of the techniques. Data mining. This is a process of collecting unknown and comprehensible information of data and making KDD. KDD means knowledge discovery from databases. Okay, so knowledge and KDD is used for making decisions. Okay, so people call KDD and EDA things of that nature. KDD stands for knowledge discovery from databases. EDA stands for exploratory data analysis. EDA, exploratory data analysis. But KDD and EDA both are used for making knowledgeable decisions. And data mining is a word that is used to describe all these processes for collecting and validating and formatting the details. Okay. The second one is forecasting. Forecasting and predicting are two different things, but although it's used synonymously. Okay, forecast is that you are actually looking for outcomes y of n plus 1. Okay, y of n is today's sample, y of n plus 1 is tomorrow's sample, y of n minus 1 is yesterday's sample. If today is n, y of n, let's say weather, right? Today is y of n, and okay, today is this. Okay, tomorrow is n plus 1. Day after tomorrow is n plus 2. Okay, and so on and so forth, n plus 3, and so on and so forth. Today is n, and n minus 1 is yesterday, n minus 2 is day before yesterday, and so on and so forth, the past. So based on the data points, if it is so based on the data points, you will actually able to do some sort of forecast with the border. Okay, so this is called forecasting. So in other words, and picture speaks more than words. So that's what I drew there. Predictive analytics is a process of historical analysis to analyze past and predict the future patterns. Okay, it could be trend analysis, it could be risk versus reward, anomaly detection, seeing how an estimation of a specific condition happens. So that's predictive analytics. Text mining. I think we have used in NLP a lot of text mining. NLP, natural language processing, is part of text mining. Text mining is for you to categorize words, like enumeration, right? I know a lot of Java programmers are here. You have A, B, and C as classification, or probably medium, low, and high. Okay, or you'll have male and female. Okay, now you also have for true or false. Okay, you have multiple classifications like that. You have good, better, best. Okay, so you have all these classifications. So you can actually do enumeration, enum. I don't have to explain that. Enum is in Java, you can actually assign the words, right? You can actually put 0 for something to represent. So you can actually put 1, 2, and 3. You can actually put true as 1 and false as 0. You can actually put 1 for male, 2 for female, or things of that nature. So any of these things are categorical variables, and these categorical variables, enumeration of that is forms basics of text mining, so that the computers will understand what you're doing. So it also has an entity relationship. So you have two different entities. If A will come, B will be next to A, and C will be next to B. So that's something that you can actually formulate in the text mining. So those are all the patterns that you follow. If I say the, then I'm expecting a pronoun next to it. Okay, if I'm actually using at, I'm using a location after that. If I use where, I'm using dependent. So those text dependencies are all there. If I use and, it means that I have something else in sequence in the next. So those all forms text mining. Okay, web analytics is a way for you to. I know you might have had multiple websites. You might have blog sports. It's all about how efficiently people click, how many clicks are there, how many retention, what are the attractive rates, how some of the KPIs are like, clickability score, how quickly page rank exists, and how many seconds it's there, it is available to load the page, and if people load the page, when do they abandon the page? They consider a form that you're writing a form to create a new email address, let's say, or anything, and if the form is pretty long, you'll abandon it. You'll start with first name, last name, and then all of a sudden you'll abandon it. Can we detect that? Can we say how the cookies work? What are all the other sites that he has created. You don't believe me? You just go Google for winter jackets, and then close all the window. Tomorrow, come back and say that just start Google something, and then automatically on the side you'll actually say winter jackets available, at the nearest store at so much discount. How did the computer know that I'm shopping for winter jackets, or probably I'm in the mindset of that? Okay, and you can use, if you're smart analytics person like me, you can use it for your advantage. For example, someone is PMP, who's that? Venkat is a PMP, right? So I'll pick on it. I was actually searching for cheap PMP course that's available. So first day, I go to my computer and say that, PMP training deals or something like that. Okay, and then I search, and then I close all the window, and then I open it again, and then I normally do whatever I'm supposed to do, and all of a sudden I'll actually get 20% discount for a course in CollabNet, maybe for CollabNet for Scrum. That's how I subscribe to a Scrum training. So things like that, you can actually take it for your advantage. So those are all used for web analytics. Okay, ANN, artificial neural networks. People know what neural networks are. Neural networks is a linkage of the representation of what brain cell will have. Okay, so for example, very, very, very simple. Okay, this is 101. This is what I read in my graduate school about 20 years ago. Okay, so we have this one. Okay, now I have cells. I call cell 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 cells. Now I actually write a word A. Okay, so I know that cell number 2, cell number 4, 5, 6, 7, and 9. So these are all will be given once. So these are all given once, and zeros are all like 1, 3, 8. 1, 3, 8 are all zeros. So this is the representation of A. So A is represented as, if these digits are all ones and these digits are all zeros, it means A. Okay, so we do a training. Some people actually can say, I can actually write A like this. Okay, and the same table gets changed a little bit, where I can actually say now 1, 2, 3, 4, 5, 6, 7, and 9 are all ones. Okay, zeros. Zero table will have only one entry, I think 8. So if this is the case, then it's A also. So you can actually write A like this or A like this with this pixel. So if you have a 9 by 9 pixel and you split A into 9 by 9 pixel, and based on which pixel gets the light, you put 1 and 0, and you can actually train the model. So that is the example of neural networks. So likewise, you can actually train H and everything. Of course, it has a lot of errors. Neural network goes with training. The more the number of training samples you get, the better that it gets. So neural networks is that. So ANN is exactly that. So basically, the definition goes like mathematical models, computational model that tries to simulate the structure of biological neural networks. Okay. Association rules mining. Rules mining is very, very simple. You have rules, and I told you example of market basket analysis. Maybe how you can actually do an association with one rule with another rule. For example, if a condition says based on the gender, you always have a rule very close to it based on the age. Okay, so you have age and gender, those two as independent but associated rules. But if you have, let's say, a child, you cannot actually have the parent's age cannot be less than 20. So if a rule says that if a question is being asked, what is your age, and the person enters, my age is 16. Okay, I cannot actually ask a question. What is the do you have any children? So that's an associated rule. So you can actually do a rule. I work in a company which has more than 20,000 rules. 20,000 rules, yes. 20,000 rules across multiple lines of business, for commercial space, for business operations, and in that I take care of. I lead a data strategy group which takes care of business owners, which is the most complex, and I have about 2,500 rules in there, which contributes to the entire philosophy of the company. And we use associations like that says that, okay, if you have a pizza shop, you're not, we'll not ask you laundry shop. Although a owner that I know in the data, it says that one of the owner has a pizza shop and a laundry shop in the same strip mall. He owns two things, of various different businesses. So ARM is that. Okay, classification. We spoke about it a whole lot. Classification is how it could be mutually exclusive and mutually exhaustive. So that's the classification. And clustering also is very similar. It's an unsupervised learning mechanism where you can actually cluster multiple things. I showed you a figure in the previous picture saying you can cluster multiple things together. Okay, so this is the cluster. So this we can call it as cluster one. People here, if you look at car example, right? Car example, you'll see that several cars who have high mileage cars, they could be hybrid. So those are all classification and clustering of that. Decision trees, we covered that already. So based on intuitive learning algorithms, even interpreted by layman. So the decisions goes like this. So with what confidence it goes here, and with what confidence it goes here, and what confidence it goes here. Each of them will have a confidence interval, a confidence band. So you have 20% chance, okay, for an event. And in this, you actually have maybe 10% chance. In this, you have maybe 15% chance. Then you have, so every time you go through this, you have rejections. So from the rejection, in that 20%, you can have another maybe 50% chance here, and then 50% chance here, right? So it could mean anything. And here you can actually do a classification of this too. So usually it's all binary, and you make a decision whether you go this way or this way based on a threshold, and that threshold is also analytics driven. Can I actually make it if it is more than 0.2? If a variable is more than 0.2, it means that I'm going to this route. If it is less than 0.2, I'll actually go to this route. Similar discussions are like even for quotes, the price and everything. So this is how price is determined. This is how people determine how they shop. What are the characteristics that they develop? How do you do multiple things? So decision trees are very fundamental of analytics. You will use a lot in decision trees and random forests. So we'll cover that in a larger way. Descriptive statistics is another way for telling EDA, exploratory data analysis, or KDD. Okay, KDD is knowledge-driven, knowledge discovery in databases. EDA stands for exploratory data analysis. Descriptive analysis says you actually have contingency table, QQ plot. You actually do a histogram. You say that, okay, so many people have observed this. This is a simple histogram plot. We can actually, so this is a histogram, and then you can actually say that, okay, this is probably a Gaussian curve. So those kind of things is what descriptive statistics are, and you can actually do bagging and things like that, based on what you see. Okay, regression analysis, we already spoke about regression analysis. Support vector machines, SVM, is give me a second, someone is reaching out. Okay, SVM is a machine learning based induction. It's pretty robust. It has a lot of theoretical background. It's used for classification. It's used for mining for multiple things. Okay, so we can actually give an example of SVM. When you have more than 64 different, let's say, columns or variables, how do you combine those into forming maybe a different plane? So you have an x-axis, you have y-axis, y-axis and a z-axis, right? So then you can actually represent a plane that would form this one. But how about this plane becoming an axis? Then you actually form a plane like this, so which is mutually orthogonal. So this is the kind of representation. So instead of this axis, I'm actually using this axis, and then I draw a ball. So this ball can be represented in y, x, and z, or I can actually put it in theta, omega, and gamma. So theta, omega, and gamma, it's a radiant transform. So I can actually do a radiant transform of x, y, and z for this particular spot, and I can actually represent the same spot in a different plane. I can do a theta, omega, and gamma angle. So it's a you've heard about Cartesians, the Cartesian plot and the other plots. So support vector machines is a way for you to see how you can actually create these orthogonal dimensions. So we call it as dimensions. This is dimension. 3 dimensions can be multiple dimensions. This 3 dimensions can be Cartesian, x, y, and z. This 3 dimension is y, omega, and theta is you can actually use Radon transform and do a transformation of this. Similar to MP3. MP3 audio compression and video compression works this way. You present the same point in a different dimension so that it could be compressed. So from time series, they actually go to frequency domain. When you do time series to frequency domain, for example, this is wave file, and you actually compress it into frequency domain, and you can actually play it back in frequency domain to wave file. Making sense? So those are all fundamentals of SVM, but all the examples that I gave you are all deterministic, just to give you an example, but you can actually do in analytics as well. Okay, so deterministic versus analytics are 2 different things. Time series analysis is like telling, if you have gone to the fountains, when is the next fountain, that next faithful geyser going to burst. If you've gone to Yellowstone National Park, you will actually see a old and faithful geyser. That's called old and faithful because you can predict it very quickly, very accurately. And if you go there, in the notice board, it will tell you when the geyser will erupt. And you can actually go and YouTube it. For people in India, just YouTube old and faithful geyser. And you'll see that when we went, we were astonished. It says 18 minutes to the next geyser eruption. I'm like, how can you predict the next eruption is going to be 18 minutes accurately? Because of time series analysis. Okay, and exactly in 18 minutes and maybe 20 seconds, suddenly an eruption came all of a sudden. And that eruption lasts about less than 1 minute. And after that, it stops. And then the ticker went that next eruption in 16 minutes. So it has two variables. One variable is the length, the duration of the eruption itself. So based on the duration, if this eruption lasted maybe 40 seconds, the next eruption, the model will take that and compute it, and will tell that, okay, the next eruption will come in 16 seconds. And the same thing with volcanoes as well. Okay. Okay. So with that, we close the chapter of all the predictive models. So I want to summarize one more time. Predictive models can be two types. One is unsupervised, and the other one is supervised. Okay, in supervised learning, you will have neural networks, decision trees, SVMs, logistic regressions, and things like that. In unsupervised, you have link analysis, clustering, text mining, classification, anomaly detection, those kind of things. Okay. So we saw data mining, forecasting, predictive analytics, text mining, web analytics, artificial neural networks, ARM, classification, clustering, decision trees, descriptive analytics, SVM, regression analysis, time series analysis. I know it's a lot of words, but I think it's a very, very solid foundation for you. So it will not be foreign if in the future classes, if we use any of those techniques, or you come across any of these things, you pretty much know. And you also know model lifecycle development, some of the value generation, things of that nature. So let's go now, shift gears into tools. Attensity is a tool that I use a lot for text analytics, although right now Solr and other things are all pretty good, that you could actually use it. In Python, you can actually have NLTK package, which uses, there is a TM package that if we have time, we'll introduce in R. But I want to tell you that, in R, I'm not going to go through all the packages. Okay, that's up to you, your interest, and there are 5,500 packages. You don't want to learn all the packages. It's not possible, and you cannot expect me to teach you all 5,500 packages. In fact, I don't know. So I will teach you. I'll demonstrate what are the important ones, and you can actually take it from there. Okay. So Google Analytics, will not touch Google Analytics too much. IBM has two of things, SPSS and other content analytics, one for unstructured data. Megaputter is also very famous for data mining. Open is R. So R is a free software environment. So we'll be focusing on the open source tool R for this particular class. But what are all the other tools is what I'm just listing, so that you know the lay of the land, for you to understand the field. The SAS is pretty famous. SAS Enterprise Guide and Enterprise Miner is very, very useful. Enterprise Miner is something that is really clickable, and many people said that R is not click. You'll have to write programs for everything, so it's the difference between Unix platform and Windows platform, right? So that's what our Enterprise Miner is. But if you do not like writing code in R, I will share with you. Some of them are management folks here who are attending this class, not purely programming folks. So for them, I'll actually give you a tool in R that would spit out R code. How cool it is, right? You actually go through multiple Java user interface and click some of the data that you want to do, and then click generate, and it will automatically generate the R code for you. And so you could use that. I'll actually share with you the packages, and I'll show you a demonstration of how we use it. Statistica, you'll come across Statistica quite a lot. Very cheap package. It's not very cheap in the sense that cheap. It's cost-effective package to do that. Okay, power of perspective. I did not know who are all from mathematical folks, who are all statistician and machine learners, machine learners are people who think the machine can learn by the data itself. Statisticians are people who think that I need to tell a certain proportionality how it could be fit. For example, a distribution. Statisticians always go with distribution. Let's assume that the data is distributed Gaussian, or let's assume that the data is distributed chi-square distribution or Poisson distribution. But here you don't have any a priori knowledge of that. Okay, that's one of the differences between a machine learner and a statistician. How you can actually do an assumption versus the confidence interval itself. Machine learners have no notion of uncertainty because the machine will learn those uncertainties and gaps itself. But statisticians always want to know what are the uncertainties, what is the confidence interval, and things like that. So that's about it. Okay, there's another company you can actually refer to. It's called IASDI, AYASDI. Google them, look at them. They are using something called TDA. It's the latest of the greatest trends that's there. It says the data has shapes, and those shapes. So this is an example of clustering. So usually without other things, we'll actually use cluster analysis. But these guys says cluster analysis will go only a few distance. They want to optimize that clustering and wanting to work with it. So they are actually doing something called a topological data analysis, which is graph theory as well as clustering in a visual format. And they use tools for that. For this class, on this course, we are not going to talk about TDA because I myself do not know so much. I'm trying to learn TDA a little bit because it's just up and coming. It says shape of the data matters a lot. It says persistence, homology, so things like that. So, and then fractals is something that's very, very, very common in financial data. I know that several people are from Citigroup and JPMC and all. So you would end up using fractals. I can share with you my white paper that I wrote on fractal analytics. I used fractals, a sort of fractals for wavelets for image processing in my patent that I published. That was in the year 2005, so more than 10 years ago. So I do not know first-hand information right now how it has all evolved so much, but I'm no longer in image processing world, but it is used for cancer detection. My transform basically was for tumor cells and segmentation of tumor cells images, and also satellite images for denoising of images, those kind of things. Yeah, you can actually take my thesis presentation also from my University of Texas, but it also has fractals in there. So it's basically saying how multiple iterative blocks can actually represent a larger block, which is totally different from the iterative blocks. So we use a lot of autocorrelation. So we'll explain autocorrelation, but this is a few examples of how to model with Brownian motions, and for example, influenza, like illness tracking, ensemble modeling, and things like that. So if you see, most of the techniques that we use are all in general pretty okay. Okay, it's about efficiencies even in that small world of smaller efficiencies, and how do you make it more efficient is what the question is. So we'll actually look at the foundational aspect, and once upon that you can actually do multiple things after that. So this is the last slide. I want to tell you that there can be, in an data analytics world, this is without Hadoop or big data. Okay, in the analytics world itself, you have multiple roles. You can be a statistical analyst, you can be a data miner or predictive modeler, You can be a forecaster, market researcher, text miner, analytics architect, or a data strategist, or a data analyst. Okay, so if you know the basics of analytics models and you understand it, then understanding the roles will be very easy. So if you're heading up a group in your company that has to take up analytics project, you might want to ask them, what are the different roles that's there and how many positions you're looking at, or what are the few modeling techniques that you probably use. So those kind of things will drive the team behavior as well. Okay, so with that, keep discard. Okay, with that we come to the end of slide number 1. Week 1, right? This is week 1. Okay. Okay. So this is about Hadoop ecosystem. I promised you that I'll actually go through some of the basics of Hadoop. So it's a lot of fluff. You can actually get it from the internet also. So I'll be very brief, considering the time. It's so we have almost an hour with us. So I'd rather focus on how to install R, what is the tools like, things like that. That's more important at this time. So Hadoop is a tool that, or an ecosystem that was developed to handle multiple formats, large data sets in a massively parallel environment. And those massively parallel environment did not was existing even before Hadoop's innovation, but they were all very expensive. For example, SAN networks and your SQL farm. I'm pretty sure you're all working in big organizations. They have a SQL farm by themselves. It's a massively parallel architecture MPP that has so much computational power, but also it has a huge cost. Now Hadoop is a simpler version where they use a tool that could enable even bunch of utility framework, which is your laptops, or it could be any of the desktops that could utilize the computational power from conventional systems, not just server systems. So can we formulate a framework which would say that, okay, can you give the data and the processing to n number of nodes and collect the data back and process the data back again and to represent it. So Hadoop actually is a framework which will actually do a mapper and a reducer. Mapper distributes the data into n number of nodes. The n number of nodes takes the data and then does the program. When it distributes it, it also distributes the program also what it has to apply for in that particular data element. And then let's say you want counting the hello world example in Hadoop is to count the number of characters in a word, right? In a word or in a Word document. So when you actually put the Word document itself in HDFS is distributed across multiple systems. So this way it's redundant and it's also recoverable. So even if multiple nodes gets down, you can actually recover the data. So similar to Facebook, Facebook has the ability to recover lost the pictures, even if thousands of nodes, are affected. Okay, so that's the Hadoop ecosystem. I know that I'm jumping between multiple topics, but traditional BI versus big data analytics, it's all about variety. It's all about workload and volumes of it. If you're looking at tens of petabytes or terabytes, then you actually look at the Hadoop ecosystem to process it. Okay, if you're looking at GBs of data, then you're actually good with traditional BI because it's more efficient, more structured, extremely very well structured. The downside of Hadoop is it's not structured, so which means that you'll have a lot of data processing, data analysis work. So remember how I told 80% of the data is formulating, prepping the data out. So it's one of the reasons for utilizing Hadoop also, that they employ a lot of data analysts in place. In fact, we are looking for a very good data analyst as well in my company. So let me know if you know a data analyst, and we can hire them very quickly. Okay, questions about businesses. So we covered this. We don't want to reinvent the wheel, but it's about why it happened, what is happening. So you have real-time data mining, forensics, and predictive and prescriptive analytics. Okay, this is an example that again I showed you about IASD example. Similar to that, LinkedIn has come up with a new map, so you can actually do a LinkedIn map, and that's pretty cool. The LinkedIn maps are extremely awesome to look at, see what you can actually do. Each and every person is a small dot in there, and every relationship between them are those small tiny lines. And the clustering algorithm, what it did was to give based on characteristics, they give multiple colors. So based on characteristics, you have multiple colors. So all the colors are all data scientists are all in the left. People who are marketing and sales people who are in LinkedIn are all on the left hand side in the orange color, who are out there. So and then you can actually use these clusters to see how you can actually predict people. Okay, Google Flu is another example too. World of data analytics. Okay, 10 use cases. Okay, again, all the 10 use cases are all going back to the 5 value generation from the Market Insight report, McKinsey's Market Insight report that came out. So these are a few use cases, surveillance, churn analysis, and things like that. So what is Hadoop? It's scalable, fault tolerant, data storage and processing system. It's self-healing, has a high bandwidth and clustered storage. Self-healing is because Zookeeper sees if a node is down, it keeps on getting the pulse. There is no pulse from it. Pulse is nothing but the ping. It does not get any response from it. So it would actually say that, okay, that node has gone. So it will actually try to recover by utilizing the rest of the nodes in its capacity and use those rest of the nodes data in itself. Okay. It operates unstructured as well as structured data. It's a very columnar databases, and all the data are stored as files. So even if you give it structured data, it's eventually going to combine all the variables, all the columns, combining it into a single column with comma separated values or hash separated values, and it's going to store it as a large file. It's going to be a file-based system, and that's how it processes it. On top of it, you have lot of layers of tools underneath the Hadoop ecosystem, so that it's pretty abstracted as to what's going on. So for example, I gave you a reference of R Hadoop. R Hadoop is a package inside R, and you will actually do what you're supposed to do in R itself, but it's abstracted so much that it would eventually go and execute itself in Hadoop environment. Okay, similar to that, the tools like Spotfire, Qlik, and Tableau, and D3, and all those visualization engine can actually read and write data into a Hadoop ecosystem because it's that abstracted. So this way, it's pretty good. Okay, write once and read times is the logic about it. HDFS. So this is the basics of HDFS. Data is organized into files. the files are divided into blocks, and blocks are distributed across clusters or nodes, and actually replace a block and have the block is replicated 3 times so that it can handle a failure, and you can actually change the